When we think about the future of our planet, it's easy to get lost in a sea of pessimism and despair. The news is filled with stories of environmental disasters, natural disasters, and the ever-increasing threat of climate change. However, as scientists, we are always striving to stay ahead of the curve, anticipate potential problems before they occur, and develop solutions to prevent them. Hello everyone and welcome to my channel. In today's video, we will explore 5 things that scientists hope will never happen to our planet. These events range from the catastrophic to the catastrophic, and each one poses a unique threat to the future of our planet and the survival of the species that call it home. From massive asteroid impacts to runaway global warming, these scenarios may seem like science fiction, but they are all based on real scientific research and observations. While we cannot predict the future with absolute certainty, we can use our knowledge and expertise to work toward a more sustainable and resilient future. So, buckle up and get ready to explore the 5 things that scientists hope will never happen to our planet. While the topics we will discuss are not exactly cheerful, they are important to understand if we hope to safeguard the future of our planet for generations to come. 1. Large-scale volcanic eruptions. Large-scale volcanic eruptions are something that I have dedicated my life to studying. These events are among the most spectacular and awe-inspiring on our planet, but they can also have devastating consequences for the environment and the people who live in their shadows. When a volcano erupts, it spews molten rock, ash, and other materials into the air, creating a cloud of volcanic debris that can reach tens of kilometers high. These plumes can travel for hundreds or even thousands of kilometers, spreading ash and other materials over vast areas of land. The impact of a large-scale volcanic eruption can be felt around the world. In addition to the immediate destruction caused by the eruption itself, volcanoes can also cause long-term climate anomalies that can have far-reaching effects. For example, the 1815 eruption of the Tambora volcano in Indonesia led to a global climate anomaly that caused crop failures, famine, and disease outbreaks around the world. One of the biggest challenges of studying large-scale volcanic eruptions is predicting when they will occur. While some volcanoes may give off warning signs before they erupt, others may erupt suddenly and without warning. To address this challenge, scientists use a variety of techniques to monitor volcanoes and track changes in their behavior. These techniques include using satellite imagery to detect changes in the shape of the volcano, analyzing seismic activity to detect changes in the movement of magma beneath the surface, and using gas sensors to detect changes in the composition of gases emitted by the volcano. Despite our best efforts, predicting volcanic eruptions with absolute certainty is still a challenge. However, by continuing to study volcanoes and develop new monitoring techniques, we can better understand their behavior and provide more accurate warnings to people who may be in danger. In addition to studying volcanoes, scientists are also working to develop technologies that can reduce the impact of volcanic eruptions. For example, by developing new materials that can withstand high temperatures and resist erosion, we can build structures that are more resilient to volcanic ash and debris. Additionally, by developing better evacuation plans and emergency response protocols, we can help to minimize the impact of volcanic eruptions on the people who live in their shadows. 2. Massive asteroid impacts. The impact of a massive asteroid can release energy equivalent to millions or even billions of atomic bombs, creating a massive shockwave that can travel for thousands of kilometers. The resulting blast can cause widespread destruction and devastation, leveling cities and towns, and causing massive fires that can burn for weeks or even months. In addition to the immediate destruction caused by the impact itself, massive asteroid impacts can also have long-term effects on the environment and the climate. When an asteroid strikes the Earth, it can release large amounts of dust and other debris into the atmosphere, blocking out the sun and causing global temperatures to plummet. This can lead to long periods of darkness and cold temperatures that can last for years or even decades, causing widespread crop failures and famine. Fortunately, the likelihood of a massive asteroid impact is relatively low. However, the consequences of such an event would be so catastrophic that we need to develop ways to detect and deflect potentially hazardous asteroids. To this end, scientists are developing a variety of technologies to detect and track asteroids as they approach the Earth. These include ground-based telescopes, space-based telescopes, and radar systems that can detect even the smallest objects in space. By using these tools, we can identify potentially hazardous asteroids and track their trajectories, giving us time to take action if necessary. In addition to detecting and tracking asteroids, scientists are also developing technologies to deflect them if they are on a collision course with Earth. These techniques include using spacecraft to intercept and deflect the asteroid, using nuclear explosives to break the asteroid apart, and using solar sails or other propulsion systems to alter the asteroid's trajectory. 3. Runaway global warming. This phenomenon occurs when the Earth's climate system reaches a tipping point, beyond which the feedback loops that regulate the climate become self-reinforcing and lead to a catastrophic rise in global temperatures. The consequences of runaway global warming are severe and far-reaching. As the Earth's temperature rises, ice caps and glaciers melt, causing sea levels to rise and inundate coastal cities and regions. Droughts and heat waves become more frequent and severe, leading to crop failures and food shortages. Ecosystems are disrupted, leading to mass extinctions and the loss of biodiversity. The primary driver of global warming is the release of greenhouse gases, such as carbon dioxide, into the atmosphere. These gases trap heat from the sun and prevent it from radiating back out into space, causing the Earth's temperature to rise. While some greenhouse gas emissions are natural, such as those from volcanic eruptions and forest fires, the vast majority of emissions are the result of human activities, such as burning fossil fuels and deforestation. To prevent runaway global warming, we must reduce greenhouse gas emissions and transition to a low-carbon economy. This means reducing our reliance on fossil fuels and increasing our use of renewable energy sources, such as wind, solar, and hydropower. We must also promote energy efficiency and conservation, reduce emissions from transportation, and implement policies and regulations that incentivize low-carbon practices and technologies. While the challenge of mitigating global warming may seem daunting, there are many reasons to be optimistic. Advances in renewable energy technologies have made them more affordable and accessible than ever before, and many countries and businesses are making significant commitments to reduce greenhouse gas emissions. Additionally, public awareness of the urgency of the climate crisis is growing, and individuals are increasingly taking action to reduce their carbon footprints and advocate for systemic change. 4. Nuclear war. The potential for a nuclear war is one of the most significant existential threats facing humanity, with the power to cause catastrophic destruction on a scale that is difficult to comprehend. The use of nuclear weapons in war has only occurred twice, in the bombings of Hiroshima and Nagasaki during World War II. However, the world has come dangerously close to nuclear war on several occasions, such as during the Cuban Missile Crisis in 1962 and the Cold War tensions between the United States and the Soviet Union. The consequences of a nuclear war are unimaginable. The immediate effects of a nuclear explosion include the massive blast wave that can level buildings and infrastructure, and intense heat and radiation that can cause immediate and severe injuries to those caught in the blast radius. The longer-term effects include the release of radioactive fallout that can contaminate the environment and cause cancer and other illnesses for years or even decades after the initial explosion. In addition to the direct human toll, a nuclear war could also have devastating environmental and economic impacts. The blast and fallout from a nuclear explosion could cause widespread destruction to infrastructure, including energy and communication systems. The loss of these critical systems could lead to food and water shortages, mass migration, and the breakdown of social order. To prevent a nuclear war, we must work towards reducing the number of nuclear weapons in the world and promoting international cooperation and diplomacy. Efforts such as the Non-Proliferation Treaty and the Comprehensive Nuclear Test Ban Treaty have made significant progress toward this goal. But there is still much work to be done. In addition to disarmament and diplomacy, we must also focus on preventing the spread of nuclear weapons to other countries and non-state actors. This means implementing strict export controls and working to prevent the development of nuclear programs in unstable or hostile regions of the world. 5. Mass extinction events. Mass extinction events occur when a significant proportion of Earth's species become extinct over a relatively short period, usually due to some catastrophic environmental event. There have been 5 major mass extinctions in Earth's history, with the most recent occurring around 66 million years ago, when an asteroid impact is believed to have caused the extinction of the dinosaurs. The consequences of mass extinction events are far-reaching and long-lasting. In addition to the immediate loss of species, mass extinctions can have ripple effects throughout entire ecosystems, disrupting food webs and nutrient cycles. The loss of key species can also lead to the loss of important ecological services, such as pollination, seed dispersal, and pest control. While the causes of mass extinction events vary, human activities are increasingly contributing to the current extinction crisis. Habitat destruction, pollution, overfishing, and climate change are all factors driving the decline of species worldwide. As many as 1 million species may be at risk of extinction in the coming decades if we do not take action to address these threats. To prevent mass extinction events, we must work to protect and conserve biodiversity. This means preserving habitats and ecosystems, reducing pollution and other environmental stressors, and implementing sustainable resource management practices. We must also work to address the root causes of the current extinction crisis, such as climate change and unsustainable consumption patterns. While the challenge of preventing mass extinction events may seem daunting, there are reasons for optimism. Advances in conservation biology and ecological restoration are making it possible to recover and restore damaged ecosystems. Public awareness of the importance of biodiversity and the threats facing species is also growing, and many individuals and organizations are taking action to protect and conserve the natural world. In conclusion, the topics of mass extinction events, nuclear war, runaway global warming, massive asteroid impacts, and large-scale volcanic eruptions are all incredibly serious and potentially devastating threats to our planet. As experts in various fields continue to study and understand these phenomena, we must work together to prevent these catastrophic events from occurring. Thank you for joining me today to explore these critical topics. Don't forget to like and subscribe to stay up to date on the latest research and developments in these areas. And as always, stay curious and keep learning.